Good morning children. In the previous class I have started the lesson light and we have studied so many topics in that lesson. Today also I am going to continue the same lesson and we are going to learn a few topics in that lesson. The first topic what we are going to learn is refraction of light. You know that when a ray of light falls on a polished surface placed in the medium, it gets reflected back into the medium. So we studied in the previous class about the reflection of light. But when the light falls on a transparent medium like a glass, the transparent medium like air or a transparent medium like a glass or water. So when a ray of light falls on a transparent medium, all the light rays is not reflected. Some of them are absorbed, some of them are reflected. Many of the light rays will pass through it. You know that, so through air, the light travels with the speed of 3 into 10 power 8 meter per second. So here I am just writing what is the speed of the light. So you have to know what is the speed of the light. The speed of the light is 3 into 10 power 8 meter per second. So this is the speed of the light. In the book it is given as RMS minus 1. This is only written as meter per second. So through air the light travels with the speed of 3 into 10 power 8 meter per second, but it does not travel with the same speed in the glass or water because these are densely medium, that is optically denser medium. So the optically denser medium like glass or water offers some resistance to that light rays. It does not allow to flow with the same speed. So that is the meaning. So here what happens? So when the light rays travel from the rarer medium here I can say as air. So when the light rays travel from the rarer medium to the denser medium like glass or water gets deviated. It gets deviated from its straight line path. You know that the light always travels in a straight line path. Here because of this one it gets deviated from its straight line path. So this bending of light about its normal is called as, that is when it transfers from, when travel from the one transparent material to the another transparent material is called as refraction of light. So what is refraction of light? In a very small way I can say is the bending of light away from the normal is called as refraction of light when it travels from one transparent medium to other transparent medium. That is the thing I have written here, the definition. So bending of light about the normal when it travels from one transparent medium to another is called as refraction of light. So when the light travels from the rarer medium to the denser medium, that is from air to water or air to glass. So when it travels from rarer medium to denser medium, it deviates towards the normal. We studied in the previous class about, I have drawn this diagram, I have shown an incident ray, it falls on the smooth surface and gets reflected back. But here what happens, when it falls, it will get deviated. This is the point of incidence. So here it is called as, we call here as point of intersection. You will learn in the coming topics. So here when the light travels from rarer medium to the denser medium, it gets deviated towards the normal. While when it travels from denser medium like a glass or water to the rarer medium like air, it gets deviated away from the normal. So this is the things you have to keep in your mind, and this can be explained with an activity also which is given in your book. It's a very simple activity you are seeing everywhere. Just you take a glass tumbler, you pour some water, put a pencil inside it. When you see from outside you can see there will be a bend of pencil when you see from outside. This is because the light here travels from the denser medium to the rarer medium and it gets deviated. So from its straight line path. That's the thing, you can able to see the bend inside the pencil when you see from outside. So this is a very simple example for the refraction of light. So then I hope you can understand what is refraction of light. So I'll just give you a recall what we studied. What is the refraction of light? The light travels, gets deviated when it travels from the transparent medium, from one medium to another medium. So when it can be said as bending of light about the normal when it travels from one transparent medium to other transparent medium is called as refraction of light. So when the light travels from rarer to denser, it deviates towards the normal when it travels from denser to rarer. You know the which are denser medium, which are rarer medium. So it deviates away from the normal, and I have explained, I have just say about a small activity which is given in the book. It is very clear, you just go through the content of that part, so it will be easy for your understanding. So that's all about this refraction of light. The next topic what we are going to learn is refractive index. So here the refraction of light depends upon the speed of the light. So I just write refraction of light depends upon speed of the light. Speed of the light. So here if the speed of the light is more, speed of light is more. So the bending means here the refraction. The bending is less. So it depends upon the speed of the light. If the speed of the light is less, then the bending of light will be more. Is more. So the refractive index depends upon that is the refraction of light depends upon the speed of the light. Here if the speed of the light is more, bending is less. That is here bending means refraction of light is less. When the speed of the light is less, the bending is more, the refraction of light is more. So the amount of refraction of light is defined or denoted by a term called refractive index. So which is refractive index of the medium, which is the ratio of speed of the light in air to the speed of the light in the particular medium. So I can write here refractive index, it is also called as absolute refractive index. I am just saying you the amount of refraction of light is defined by a term called refractive index. So here this refractive index is also called as absolute refractive index, and it is denoted by the Greek letter mu. This is called as mu. When we say it is a Greek letter, when you pronounce it is pronounced as mu. So what is mu? The refractive index is equal to speed, this is the ratio, speed of light in air, as it is a ratio is divided by speed of light in a medium. So we can write the speed of the light in air is denoted by the letter capital C, and it is denoted V is travel in the medium. This is the speed of the light travel in the medium. So the refractive index formula is mu is equal to C by V. So here it doesn't have any unit because it is comparing the same quantities, speed only. So it doesn't have any units. The speed of the light in the medium is always less than speed of the light in air. Therefore, the refractive index of the medium of any transparent material is always greater than 1. So here the refractive index of any transparent material is greater than 1. The medium, in this medium, the refractive index will be very less. The speed of the light in the medium is always less than speed of light in the air, so that the refractive index is always greater than 1. So in your book they have given a tabular column for various mediums, transparent mediums, the refractive indexes values also. You can see the first one they gave us air, and it is denoted as 1. Whereas coming the next one you can see here in your book, water 1.33, ether 1.36, all the things if you see it is greater than 1 only. So the refractive index is always greater than 1 when you compare the air and the transparent medium. So this is the thing about refractive index. And you have one more small portion is there.
So the refractive index of one medium with respect to other medium is given by the ratio of the absolute refractive index. It's nothing, it's a very simple one, that is when you compare both the mediums, it gives you the absolute refractive index. So it depends upon the speed of the, refractive indices of the different mediums. With respect to the second medium, first medium already is given. It's not so much important, but you should know what is refractive index, how to calculate the refractive index. So it depends upon the speed of the light. The refractive index depends upon speed of the light. Here I have given the formula that it is denoted by the letter mu. It is a Greek letter, and mu is equal to speed. It is a ratio to the speed of the light in air to the speed of the light in medium is equal to C by V, and always keep in your mind the refractive index is always greater than 1. Comparing the air, the other medium will be less, so the speed of the other medium will be less, so the refractive index will be always greater than 1, and we have a tabular column also in the book. So we studied about refraction of light and refractive index.
Just I will give you recall, that is refraction of light, the bending of light. Just very simple word you can say in mind, bending of light. Okay, when it transfers, when it moves from, or when it falls from, or it travels from one medium to another medium, that is called as refraction of light. The refraction of light depends upon the traveling of light either from the rarer to denser, how it moves away from the normal or move towards the normal. Everything I have explained with a small activity also, which is given in your book. The second topic what we deal is refractive index. So the speed of the light depends upon, the refraction of light depends upon the speed of the light. If the speed of the light is more, bending will be less. If the speed of the light is less, bending will be more. So here the amount of refraction of light is defined by a term called refractive index. It is also called as absolute refractive index, and it is denoted by the letter mu. So mu is nothing but the ratio of the speed of the light in air to the speed of the light in the medium, and it is denoted by the formula C by V. C is given for speed of the light in air, and medium is speed of the light in medium is V. It does not have any unit because it is comparing, it is a ratio between the same quantities, that is speed. So it does not have any unit, and the refractive index is always greater than 1 when you compare. That is, the speed of the light in air is always greater than this medium only. So the refractive index is always greater than 1. So this is the thing about the refractive index. The next topic what we are going to learn is Snell's law of refraction. Here when a light travels from one medium to other medium, it obeys, I will just write the topic first, Snell's law of refraction. We studied about law of reflection in the previous class. This is law of refraction. So when a light travels from one medium to other medium, that is one transparent medium to other medium, it obeys two laws, which is called as Snell's law of refraction. That is nothing but, when I draw, this is a medium, here it is a normal, that is normal is a imaginary perpendicular line. When a light falls here and it gets deviated, so this is the incident ray and this is the refracted ray, and this is point of intersection, and this is the normal, the imaginary line. So this is incident ray, this is refracted ray. So the incident ray, the refracted ray and the point of intersection all lies in the same plane. So this is the first law of refraction. So the incident ray, the refracted ray and the normal at the point of intersection all lie in the same plane. The second one, the ratio of sine of angle. I'll just write the point so that you can make a note. The first law is the incident ray, the refracted ray, and the normal at the point of intersection. There we studied as incidence, intersection lies on the same plane. This is the first law. The second one, the ratio of sine of angle of incidence, sine of angle of incidence to the sine of angle of refraction is equal to the refractive index of the medium, which is constant. So I can write here sine I by sine R is equal to mu. So this is the second law, that is the ratio of sine of angle of incidence to the sine of angle of the refraction is equal to the refractive index of the medium, which is constant. So sine I by sine R is equal to mu. In the book it is not given, it is given as sine theta 1, sine theta 2, that is they have given the angle as theta 1 and theta 2, that's why. So I just write here for your understanding, sine I by sine R is equal to mu. These are the two laws should be followed when it gets refracted. So the laws of refraction, this is called as Snell's law of refraction. Snell is, so here the laws are the incident ray, the refracted ray and the normal at the point of intersection lies in the same plane. This is the first law. The second law, the ratio of sine of angle of incidence to the sine of angle of refraction is equal to the refractive index of the medium, which is constant. So here I can written as sine I by sine R. This is the ratio. So sine I is angle of incidence, sine R is angle of refraction is equal to mu is refractive index. So these are the two laws about the Snell's law of refraction. So we studied three topics and we are going to see the next topic is nothing but dispersion of light. So you can see the rainbows, you can see when the bubbles, so some colors will be seen, the color lights, when you just see, you can see some colors. So what are these is nothing but dispersion. That colors of light is called as dispersion, that is the splitting of light into its constant colors when it travels towards a transparent medium like prism is called as dispersion of light. What is dispersion of light? Splitting of light, that is the light gets splitted when the white light, you have studied in the lower class Newton's disc, that is it will be colored with so many colors. When you just rotate you can see only the white color will be seen. So the 7 colors is formed from the white, the base is white, so you can understand. So splitting of white light into 7 constant colors on passing through a transparent medium is called dispersion of light. So I will write here the definition for dispersion of light. Dispersion, we are dealing with the topic dispersion. Dispersion is nothing but splitting of white light into its 7 colored constituents when it passes through a transparent medium is called dispersion of light. So why this dispersion occurs? What is the reason behind the dispersion? Because the dispersion occurs because of the light, the different colors. The light have different colors, have different wavelengths, and it travels with a different speed. So you know that the speed of the refraction of light depends upon the speed of the light. So here the light with a different speeds will get refracted at a different extents. So that is the thing, the dispersion occurs. That is the thing, the colors differ, that you can able to see the different colors. That's why you can say here the red light have large or longer, wavelength will get deviated or refracted, deviates less, whereas the violet color light have smaller wavelength, deviates more. So this is the reason, because the light will travels with a different wavelength and different speeds. You know that the refraction of light depends upon the speed of the light. So here the different colors light will move with a different speed, so that gets deviated to their different extents. So here it is always inversely proportional to its wavelength. The refraction of light depends upon the, moreover it is inversely proportional to its wavelength. So you can see in the rainbows also. So I have given here which color have the larger wavelength is nothing but the red light. So it deviates less, whereas the violet light have small wavelength, so it deviates more. So you can see in the rainbows also how the rainbows are formed. You can see after the rain, the rainbows will form just opposite to the sun, because the rays falls on the droplets which are gathered in the clouds will be get dispersed, and the cluster of water droplets together will make a rainbow. That is the thing, we can able to see the rainbow. Always it will be forming just opposite to the sun rays, because the light rays from the sun only falls in the water droplets which are suspended in the clouds, gets deviated, gets refracted and forms the different colors, looks like a band of colors will be there. So that is the reason for the formation of rainbow. This is because of dispersion of light when it falls on a transparent medium, when it passes to the transparent medium. So I have completed this lesson with these topics. The lesson got over. So we have studied, what are the topics we studied today is refraction of light, refractive index, and we studied about Snell's law of refraction, and also we studied about the dispersion of light. So please have your book, you just go through the content, so it will be easy. This lesson is very easy to understand also. I hope my teaching is very easy to understand, and we have some numerical problems that will be taught. You just have a look of the numerical problems in your book. So here in the numerical problems, page number 34 in your book. It's very simple. Just writing the steps, you can follow it. The first sum which is given, I have given the notes also will be there, it will be clear in that one. Anyway, I will just teach you. The first one they given as the radius of curvature of a spherical mirror is 25 centimeter, find its focal length. So we studied this one in the previous class, like what is the formula to find the focal length, that is we know that f is equal to r by 2, that is the formula. So this is numerical problems in that lesson. Book back, it is given at the book back. I will just write the question number so that it is easy for you to understand. So the question number is 1, and the first they given us the radius of curvature of the spherical mirror is given. So r is given as 25 centimeter and find its focal length. So f is equal to what? So we know the formula, f is equal to r by 2. So is equal to r is 25 by 2. When you divide, you will get as 12.5. This is
focal length, so it will be in meter or centimeter, it depends upon the units. So that's all for the first sum, very simple sum, only the formula if you know you can able to do the sum. So the radius of curvature is given, find its focal length, f is equal to r by 2, r is given as 25 centimeter, so 25 by 2 is, so you know this calculation. That's all. The next sum is also very simple, using the formula to find the number of images. So they given the angle as theta is equal to, the second sum, theta is equal to 45 degree. They have given us 45 degree and they asked to find number of images. We studied this formula, it's called n is equal to 360 degree by theta minus 1. This is a formula we studied. So here we apply 360 degree, that is 360 by theta is 45 minus 1. So here we can write, we can simplify this one, 45 and 360 will go by 9 tables. So here 9 we can directly cancel, so we have to take LCM and do it, will be a long process, it is easy also. So you can write here as 5s are and this is 40s are, then 5 1s are, this is 8s are. You get as 8 minus 1 is, number of images formed is 7. So this is the way of finding, the formula is nothing but number of images is equal to 360 by theta minus 1. You apply the value for theta, the angle is here given as, we take as theta as 45 degree. So when you calculate, you get number of images as 7. The next is some third sum. The speed of the light is 3 into 10 power 8. We know that the speed of the light is 3 into 10 power 8 meter per second and the refractive index is given, that is mu is given. Now only we studied this formula also. So I will just rub this part and we do the sum. So they have given third sum, this is the speed of light is mentioned by the letter C, that is 3 into 10 power 8 meter per second. And they are given refractive index, so mu is given. So mu is equal to 1.5, it doesn't have any unit, and they asked to find the speed of the light in the medium. They asked V is equal to what? So we know the formula, mu is equal to C by V. So here we have to find this one only. So you just can write here, V is equal to C by mu is equal to, C is 3 into 10 power 8 by 1.5. So here, so when you cancel you get as 0.5. So 0.5 into 10 power minus 8, this is the answer for that. That's the thing we have found, the speed of light. Just you can keep in the mind, mu is equal to C by V. We have to find this V. So you bring this here and bring this one, C by mu. So 3 into 10 power 8 by 1 by 5. When you cancel it will become as 0.5. So 0.5 into, when it comes up, it becomes as 8. So that is the thing. So 10 power 8 by 0.51 into 10 power 8.5. When you bring it down, it will become as minus 8. So that's all about the numerical problems. Only 3 sums at the book back. You will get in the material also very clearly so that you can understand. Any doubts you just clarify through the groups. I hope everyone understand this lesson got completed. Let us see in the next class. Thank you boys.